Okay, here's part 2 of the practice test. What I'm going to do is skip to what I consider to be the easy ones and then come back to the hard ones. So I consider this to be a hard one. We already did 20 in the previous video. This is a hard one. This is a hard one. Although I'm just going to give you a way to guess at this one. I'm not going to try to teach you that one. Same for this one. Okay, 25. We finally, this is one we did before. We're going to do 25. We're finding the derivative of function. And the way that I've shown you to do this is when you have the variable in the denominator, we rewrite it as negative 10 x to the minus 1. Just to review, if you had something like 1 over x squared, that's the same as x to the minus 2. So this has an understood 1 on it. That's why we can write it as x to the minus 1. Now to find the derivative, the formula for the derivative, f prime of x, we multiply the exponent, the negative 1, times the number in front. Negative 1 times negative 10 is positive 10. We write down the x, and then we reduce the exponent by 1. We make it 1 smaller than it is. So 1 smaller than negative 1 is negative 2. That's a formula for the derivative, which I can rewrite that with a positive exponent like this. So we're asked to find the value of the derivative when x equals negative 12. So I'm asked to find f prime of negative 12. So I'm going to take this negative 12 and plug it in for that x. 10 over negative 12, the quantity squared, is 10 over 144. If you look at the set of possible answers, it's not over here. But the fact is I can divide the numerator and the denominator both by 2. So it reduces to 5/72. There you go. Okay, on to board 4. Oh, this one couldn't be easier. Direct substitution. Just put 0 in for x. As long as I don't end up dividing by 0 or taking the square root of a negative number, I can use direct substitution. So the limit as x approaches 0 is 4. 0 plus 4. Easy. Now on this one, we might try direct substitution first, but if I put negative 4 in for x, I get negative 4 plus 4 is 0 in the denominator, and I get 16 minus 16 is 0. So I would be getting 0 over 0. So I'm thinking maybe there's a way to rewrite this. And there is. X squared minus 16 can be written as x minus 4 times x plus 4 all over x plus 4. I factored that numerator. And now the fact is, as x gets close to negative 4, but not equal to negative 4, these cancel out. So now I can try direct substitution. Put negative 4 in for that x, and I get negative 4 minus 4 equals minus 8. There it is. And if you want to convince yourself on a calculator, try putting in negative 4.1. And you'll see that you get something that's pretty close to negative 8. Okay, next board. Another easy one. We got a graph. We're asked to, and this is a written assignment, I guess, find the limit as x approaches 2 from the left. Remember, on a number line, the minus numbers are to the left of 0. The positive numbers are to the right of 0. So when we have this little minus sign here, that means we're coming in from the left. So as I come in from the left, I'm following this graph. When I finally get close to 2, I'm getting close to the y value of that point right there. Well, the y value of that point is 1, 2, 3, 4. So the limit from the left is 4. The limit from the right of 2 means I'm coming in this way. And as I get close to 2 but not equal to 2, just getting closer and closer, I'm getting closer and closer to the y value of that point, that open circle, which is 1, 2, 3, 4, negative 4. Okay? Those are your answers. Determine the limit. Determine the limit if it exists. Okay, there's two answers to each of those, to that problem. Board 6. Use graphs and tables to find the limit. Identify any vertical asymptotes. So the denominator equals 0 when x is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the vertical asymptote. I'm asked, what's the limit as we come in from the left of 10? That is, we're coming in this way. Well, a number just to the left of 10 would be like 9.9. So picture putting a 9.9 in here. 1 over 9.9 minus 10 equals 1 over negative 0.1, or negative 1 over negative 1/10, or negative 10. We're doing that just to convince ourselves that the limit is negative infinity. Okay. You could, it says use graphs and tables, so you could go to Desmos and you could make a table of coming in from the left of 10. We could say 9.9 and figure out what y is, which we already saw was negative 10. We could put in negative 9.99, get even closer, 9.999. On a calculator, 1 over 9.999 minus 10, you'd see the numbers get bigger and bigger and bigger, but in a negative direction. So 100, negative 1,000. We could make this number get as big as we want. So we know the graph is going to go like this. Next case, board 7. Hard problem. I'm just going to show you how to do this. 31, easy problem. Position function. If you take the derivative of the position function, you've got the velocity. If you put this number into the velocity function, you get the instantaneous velocity. This is kind of, forgive me, a stupid problem. All right, S of t equals 7 minus 14t. So S prime of t which is the same as velocity, is the derivative of this function. And the shortcut that I've taught you is that the derivative of a constant is 0. The derivative of a number times the variable is just the number in front. So the velocity is always the same no matter what number you put in, because there's no t to substitute for. Now I think they're expecting for you to get credit on this one to do this, the limit as h approaches 0 of s of t plus h minus s of t over h. So I'm just going to show this to you. This is the limit of a difference quotient. So that would equal, what is s of t plus h? I put t plus h in for this t. This is like the format for the s function. So s of t plus h means 7 minus 14 times the placeholder for t. I'm putting in t plus h. From that, I'm subtracting s of t, which just is this, 7 minus 14t. Again, all over h. Now remove the parentheses and watch what happens. Seven minus 14t minus 14h minus 7 plus 14t all over h. Start combining the similar terms in the numerator. The 7 and the minus 7 combine to 0. The minus 14t and the plus 14t combine to 0. I've got minus 14h over h. As h gets close to 0, these can cancel out, and I'm just left with the constant 14, negative 14, which is the same thing we get with the shortcut. So the answer to number 31 is negative 14. Okay, now let's go back to previous boards and let's see if we can figure out what's going on here. And this is how you should take the test. Go through and do all the ones that you have a shot at, then come back and work on the hard ones. Okay, so let's just draw a quick sketch. The vertices of the hyperbola are at 0, 6, and 0, negative 6. Okay. A hyperbola has two branches. And they go through the vertices. So those are the vertices. The branches go through the vertices, opening downward. If the vertices were along the x-axis, then they would open left and right. Okay. So when the parabola opens upward, like this, that means the y squared is first. Well, these all have the y squared first, so it's got to be one of these. But the vertex is this number, is this 6 squared, negative 6 squared. So it's got to be either this one or this one. So we know we're going to start out with y squared over 36 minus x squared over, it's either 25 or 100, and equals 1. Question is, how do we figure it out? Well, it turns out that the square root of this number is 6. That's like the a. Is to whatever the square root of this number is, that's what we don't know. That's the b. That is the slope of the asymptotes. So that equals 3/5 plus or minus 3/5. So if I cross multiply, I get 3b. I'll move up here. 3b equals 30. So b equals 10. So b squared is 100. So that's what goes here. There's your answer. Board 2. I'm going to pause the video and bring up the unit circle. Okay, there's the unit circle. Whoops, I covered it up. So for this problem, polar coordinates, the point is 3 negative pi over 3. What does that mean? It means we rotate in the negative direction pi over 3 units. So this is negative pi over 3. And we go out 3. So this distance is 3. They want us to find all the polar coordinates of this point. Okay. Just so you know how many degrees that is, negative pi over 3 is right here. Oh, I can't draw on here. But that's 60 degrees. So this is like negative 60. Okay, so let's see what our choices are. They still want us to go 3, whoops, 3, comma negative pi over 3. Then we add on, this is 2n pi. And what that means is that we can go 2 pi in any direction, and we'll be right back where we started. That's what 2n pi means, where n is any integer, any number, including negatives. So we can go around as many times as we want, and we'll end up right here. Another way to end up at this point is to rotate to here and then go backwards negative 3. So how many degrees is that? Oh, well, they go, all right, it's 180 degrees from here. So they go, and pi is 180 degrees. Now if we went 2n pi, we'd go 360. But if we go 2n plus 1 pi, we'll go once around and then halfway around, and we'll end up in the opposite direction from this angle, but then we go in the negative direction. So the one that works is, I'm going to pause the video because I was having trouble seeing the difference between these two, but we need 2n plus 1. 2n plus 1. It's one of these two, but we need a negative 3. We've got to go backwards. So this is our answer. And hopefully you can just pick that out on the test. Without doing all of this. Okay, for the negative opposite, we're looking for the 2n plus 1. You might have to guess. All right, I'm going to pause the video and go to Desmos for the next one. Okay, Sarah, I just can't think of any way to teach this to you that you're going to understand without extensive lessons and formulas. So I'm going to show you what it means on Desmos, and then you're probably just going to guess. It's probably going to be y-axis or x-axis. Here's what it looks like on Desmos. R equals 3 minus 4 sine theta. As a matter of fact, usually we graph this on what's called polar coordinate paper. So this shape is symmetric about the y-axis, because you could fold the paper along the y-axis and the left image would lie right on top of the y-image, the right image. So the right answer to this one is y-axis. If we go on to board 3, r equals 3 cosine 5 theta. R equals 3 cosine 5 theta. Okay, I'm going to go to Desmos. And I graphed r equals 3 cosine 5 theta. There's the picture you get, a 5-leaf clover. The fact is that if you folded this graph along the x-axis, the two images would overlap each other. I'm not even going to try to explain it. So just normally, when it's just a cosine sitting out here by itself, it's x-axis. Okay, that's going to have to be your guess. Board 4, we did both of these. Board 5, we did both of those. Board 6, board 7, we're left with number 30. Oh, I need some room here for this one. All right, what can I say? I just want to give you a short way to do this, okay? And I don't want to give you any formulas. I just want to show you what to do. When we find the fifth roots of this complex number, we want to find the fifth root of 32. Now, they're probably going to give you a number where it's easy to figure out. It turns out that 2 times 2 times 2 times 2 times 2 is 32. So the fifth root of 32 is 2. You can do that on your calculator by going 32 to the 1/5 power. Okay, so the key is you got to know that the fifth root, whatever this is right here, is 2. So that's the number in front. And by the way, there's 5 answers to these. You're using a theorem called de Moivre's theorem. So to get the first number, first angle, we have to divide 280 by 5. So that's 5 times 5 is 25. 56. So the first fifth root of this complex number is 2 times the cosine of 56 plus I sine of 56. And I know you have no idea what this means. But you could figure out the sine of 56, and you'd get a number, and you could substitute it in, and you'd be converting this to rectangular coordinates. Okay, so we're giving complex coordinates for this complex number. Now the question is, how do you find the other 4 roots? Here's what you have to do. And again, I'm not giving you a formula, just giving you a technique. So I'm going to draw a circle out here. There's a circle. Okay, and then I'm going to draw the axes. I'll use green. Okay, and what we want to do is divide this pi into 5 equal parts, where the first part was 56 degrees. Let me use red. So I go out here 56 degrees. Okay, Sarah, I wanted to write some of this down instead of having you watch me write it down. All right, I said we got the first angle, which is at 56 degrees. And what we want to do is divide this 360 degrees circle into 5 equal parts. So we find out how many pieces, 5 pieces there are on 360 by dividing 360 by 5. There's 72 degrees to each piece. So I add 72 to 56, which takes me to 128, which is over in here somewhere. Then I add 72 to 128, which is 200, which is down in here somewhere. Then I add 72 to 200, which is 272, which is barely right there. Then I add 72 to 272, which gets me to 344. Which takes me right to there, and there's the 5 pieces of the pie. 1, 2, 3, 4, 5. So the 5 roots are 2 cosine 56, 2 cosine 128, plus I sine 128. And there's going to be 5 answers. There's five roots, 5 fifth roots. If it said 6 roots, there'd be 6 answers. If it said 2, there would be 2. Okay, so the numbers that I have circled over here in blue, that's your answers. Cosine, so I won't write them all down. The last one, 1, 2, 3, 4, 5. The 5th one is 2 cosine of 344 plus I sine of 344. And just so you know what we're saying, if we took each of these complex numbers and raised them to the 5th power, this is what we would get, that complex number. Okay, so that's what we mean by finding the 5 roots. And here they are in complex number format. They're on the edges of this circle, where the radius is 2. Okay, I think I covered them all. Let me go back and look. Yes, 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 yes. Okay. Hopefully you get a chance to watch this tonight, and we can talk about some shortcuts maybe for tomorrow's lesson. Have a good one.